Welcome everyone. Is it visible? Hello. Hello. Is it visible? Can you hear me? Am I audible?
Your voice is too low.
Hello. Hello. Now?
Yes, sir. Now it is clear.
Okay. 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 Thank you. Okay. So on today, I would like to discuss about the IO interfacing, means the input output device interfacing with the microprocessor 8085. So all of you know how many types of IO devices are available. Those can be interfaced with 8085. Like as for example, keyboard, different types of switches, LED display, semi-segment LED displays is there, printer is there, scanner is there. So all these are can be interfaced with the microprocessor to perform as input and output function. Okay, because these are very important in the uh, context of microprocessor, because without them no real world data can be handled. Okay, no real world data can be uh, input to the microprocessor, and no output uh, can be generated. Okay, so that's why these IO devices are very important to uh, connect with the microprocessor, because the total microprocessor system is based on the processor, memory, input and output, and it combinations of these creates a microprocessor based system. Okay, so the approach to designing an interfacing circuit for an IO device that is determined primarily by the instructions to be used for data transfer. Now, an IO device that can be interfaced with the 8085 microprocessor either as a peripheral IO or memory mapped IO. Okay, or as a memory mapped IO. So there are two methods, either peripheral IO or memory mapped IO. Now, peripheral IO is also called IO mapped IO. Okay, so in the peripheral mapped IO or IO mapped IO, the instructions in or out, all of you are familiar with the instruction in and out instruction. So these are used for data transfer, and the device that is identified by an 8-bit address. Okay, but in case of memory mapped IO, memory related instructions are used for data transfer, and the device is identified by a 16-bit address. However, the basic concepts in interfacing IO devices are similar in both methods. Okay, so what happened in peripheral mapped IO or IO mapped IO? Now, the 8085 microprocessor, it has two instructions for data transfer between the processor and the IO device. Okay, first is in and second is the out. Now, the instruction in inputs data from an input device such as keyboard and into the accumulator. Okay, so it takes the input from the keyboard and send it to the accumulator. Okay, and the instruction out that sends the contents of the accumulator to an output device such as for example LED display. Okay, now these both instructions are actually 2-byte instruction. Okay, and all of you know that 2-byte instruction means the second byte specifying the address, particular in this case. Generally in 2-byte instruction, the first is the opcode, second is the operand, but in this case that is also second byte is also operand, but that specify the address or the port number of an IO device. Okay, so So each IO device that is identified by unique 8-bit address assigned to it, and 8-bit address means 2 to the power 8, that is 256 input devices, maximum 256 input devices and a maximum of 256 output devices that can be interfaced with the 8085 as per configuration. Okay. And control signal, those are used to access input devices, output devices are different, because to get input, microprocessor needs to read something, and to uh, to send the output, microprocessor writes something. Okay, so here input refers to the read operation, output refers to the write operation. Always remember these 2 points. First one, input always it refers to the read operation, output always refers to the write operation. Okay. So in actually the control signal IO read and IO write, which are derived from the IO M bar, read bar, and write bar signals of the 8085. Uh, so these are used to activate, basically, it activates the input and output devices respectively, as I have told you earlier. So uh, already I have discussed the memory, how these are generated. So take the inputs as IO slash bar means the IO operations should be high. So logic 1 is there. So it gets to the input of this NAND gate, and read bar signal, which is read bar signal means it is active low signal. So 0 is coming in this way, so that it gets inverted 1. And if the all inputs of that non NAND gate is 1, the output should be low, which is generated as IO read control signal. In the same way, the combinations of this one and this one, it creates IO write control signal. Okay. So in the same way how the memory read and memory write control signal was generated, and it was seen in the table format, it is same here. It's the same type of signal is generated, like IO slash ember, as I have told you, that if it is 1, this is 0, this is 1, and this is 0, and this IO write signal is 1, that means it is an IO read operation. Now if IO slash ember signal is 1 but read bar is 1 and this write bar is 0, then it is called IO write operation. And if this signal is 0, IO slash ember, this status signal is 0, then whether the signal is 0 or 1, it doesn't affect, it doesn't matter, and it should be no IO read or IO write operation. So for IO read and IO write operation, this signal must be high. Okay, otherwise this will be treated as your memory related operation, and this is not your memory related operation, this is IO related operation, so it should be high always. Okay, this signal will be high. Is it clear up to this much? Do you have any queries, any doubt?
No, sir. Clear.
Okay, so next is the memory mapped IO. So in memory mapped IO, the input and output devices, these are assigned and identified by 16-bit address. Okay, 16-bit address. Now, to transfer data between the microprocessor unit and IO devices, memory-related instructions such as STA, LDA, etc. These are memory-related instructions, and memory control signals like memory read and memory write are used. So instead of IO read, IO write, here memory, as it is memory related type operation, so that's a memory related instructions are used, as well as the control signals, memory read and memory write. So this the actually the microprocessor communicates with an IO device as if it were one of the memory location. Okay, the and here in this technique it is similar in many ways to the peripheral IO technique. Now to understand the similarities, you must clear the concept of STA related operation. Okay, do you have any doubt about STA and LDA related operation? What is the function of STA? Anyone? Can you tell me? STA, so it is given as STA 3000. What does it mean?
Store the accumulator content in the 3000 address.
Yeah, good.
Yes,
And and LDA, LDA 2000.
It will
Load the
load the
accumulator
data
content
from
with
the
the from the memory address 3000.
Oh, good. So STA, LDA both are 3 byte instructions, and all of you know the function. So uh, basically the here these type of LDAX or move a comma m is also memory location, but it is indirectly specified. Okay, which I have told you earlier that m related operations can be done with the help of HL register pair, because HL is only applicable with this m related instruction. So m points to the memory location which is pointed by H register pair, and in that memory location if there is any data, that should be moved to either accumulator or from accumulator to that specific memory location using move m comma a. Okay, so you have some doubt about this type of instruction uh, which was performed in quiz. Okay, I will discuss it later after this lecture. So okay, so the I devices are some of the memory at the space of 8085. The maximum memory capacity, whether it is RAM or EEPROM, that will be less than 64 kilobytes in this method. Okay, so there are some limitation because not full address can be used for one such interfacing design. Okay, now this is very important topic, which is the difference between the memory mapped IO technique and peripheral mapped IO technique. So there are certain characteristics as per the characteristics if the device address. So according to the device address, memory mapped IO, if it is used to interface IO device with the microprocessor 8085, then the address should be 16-bit in size, but that is not possible in case of peripheral IO or IO mapped IO. The port address or device address should be always 8-bit in size. Now, in case of memory mapped IO, the control signals for the input and output devices are used as memory read and memory write control signals. But in case of peripheral IO or IO mapped IO, this is IO read or IO write. Now, in your semester exam, it may be possible to come this question in this way: what is the difference between memory mapped IO and IO mapped IO? Okay, uh, difference write the difference between memory mapped IO and peripheral mapped IO. So peripheral mapped IO is also called as IO mapped IO. Okay, so don't confuse with these two terms. Memory mapped IO, the third characteristics is the instructions which are available to connect the interfacing device with using the memory mapped IO. uh, these are valid for STA, LDA, LDA, stacks related instruction and M related instructions. And in case of peripheral mapped IO, only two instructions are valid, that is in and out. No other instruction can be used to perform uh, the interfacing technique. Uh, Data transfer. Now, in case of memory mapped IO, the data can be transferred from any between any register and IO device. Like you can write it as move A comma M, move B comma M, move C comma M. Okay, move D comma M, move E comma M, move H comma M. So any register to any memory location. Okay, but in case of peripheral mapped IO, only between IO device and the accumulator is used, because in instruction can be written in this way: in 08. So what is 08? 08 is the device address. Now what is the device address status? That must be loaded inside the accumulator. Okay, no other register is applicable. Just like in case of STA, no other register is applicable for STA or LDA related instruction. Like you can't write as STB or STC or STD. No, only STA, some memory location. In the same way, in some port address or out some port address, that is only applicable with the accumulator. Okay, so there are only two instructions in a peripheral map tower. So these instructions are applicable with or valid only with the accumulator. So data can be only transferred between the specific IO device and the accumulator content. No other register will be involved. For fifth number is the maximum number of IOs possible, because here only 16 so full 16-bit device address is used to. So 2 to the power 16 means 64 kilobytes. So 64 kilobytes of memory can be shared between the IO device and the memory. Okay, so that means 65,536 memory locations are used, or maximum input and output device can be connected in this way, 65,536. Okay, but that is not possible in peripheral map tower, because here the device address is 8-bit. So 2 to the power 8, that means 256 maximum number of devices, either input device or output device must be can be connected in this way. Execution speed, here the memory mapped IO, as the instructions are used, these type of instructions are used. So maximum number of instructions can be executed either 70 states or 13 states, but these are fixed with the in and out instructions. So always peripheral mapped IO execution state speed will be within 10 T states, not more than this or not less than this. In case of memory mapped IO, the hardware requirement is much more needed, because more number of address lines are involved, more number of address must be decoded. So hardware cost will be high. In case of peripheral mapped IO or IO mapped IO, less hardware is needed, because only 8 address lines should be decoded. Okay, here 16 address line should be decoded, here 8 address lines are decoded. So as 8 address lines are decoded, so less hardware is needed, and the circuit complexity will be much less. In case of and our other features are here in memory mapped IO, that is arithmetic and logical operations can be directly performed with the IO data, because there are lots of variable instructions are available, like add m, sub m. These are arithmetic or NAM logical instructions can be performed, but this is only to read the data and to write the data. Okay, either data can be transferred from inside to outside or outside to inside. Now that is not possible to perform any arithmetic or logical operation directly. Okay, so these are the differences between memory mapped IO technique and IO mapped IO technique. Okay. So tell me, clear up to this much?
Yes, sir. Clear.
Yes, sir.
So next is the absolute address decoding and partial address decoding. Now absolute address decoding, where all the address line must be decoded. Okay, all the address lines are decoded, like A0 to A15. Total 16 address lines are decoded. But in case of partial decoding technique, only some of the address lines are decoded. Means suppose through suppose uh, 8 address lines are decoded, all other address lines are in don't care logic, or 3 address lines are decoded, all other address lines must be in don't care, either 0 or 1. So if some of the address lines are decoded and others remaining in don't care position, either 0 or this will be 1, so that means fallback addresses can be generated. Means to connect one number of device, it needs 4 addresses. So 4 addresses will be reserved to connect one such device. So that means if 4 addresses are reserved to connect one such device, so less number of device can be connected in this way. Clear? So if 8-bit address is used, so that means 2 to the power 8. So maximum 256 devices can be used. So for 256 devices, there are particular 256 types of port addresses there. So 256, each input and output device can be identified by its port address. Okay, suppose I have written that IN00. So now in this 00, one switch is there. Next, I have given IN01. So in 01 address, one keyboard is attached. Okay, and then IN02, another switch push button is used. So I can connect maximum in this type of using the 000102, this type of addresses to define the different devices, input devices. And in the same way, you can define the output devices also to identify it. So if one address is specific for a one device, then maximum 256 possible combinations will be there. But if one device is reserved for four addresses, means 00 is same for switch 1, 01 is same to connect switch 1, 02 is same to connect switch 1, 03 is same to connect switch 1, then possibility will be less to connect the more number of devices. So less number of devices can be connected because such four locations are reserved to connect one device, specific device, and that is happened in partial decoding technique. So that is the disadvantage, actually, partial address decoding technique. But one advantage is there for a small system. If you don't need to connect more number of devices, then your cost will be minimized. And how can you reduce the cost? By connecting this total method, the interfacing method, using partial address decoding technique. Okay, and if you want to connect more number of devices, then absolute decoding technique, absolute address decoding technique must be used. So that is the advantage of absolute decoding technique. Okay, now there are certain questions coming in the exam, like can an input port and an output port have the same port address? The answer is yes. They will be uh, they will be remain same, but they will be differentiated by their control signals. Like the read bar control signal that is used to enable the input port, and the write bar control signal that is used to enable the output port. So they can be same, but differentiated by the control signal. Another question is like, in a memory mapped IO, how does the microprocessor differentiate between an IO device and the memory device? Okay, so answer will be in memory mapped IO. The microprocessor cannot differentiate between an IO and memory. Okay, it treats an IO as if it is a memory. Okay, and in that case, can an IO have the same address as a memory register? An IO and memory register cannot have the same address.
No,
The entire memory map of the system has to be shared between the memory and the IO itself. Okay. Another question maybe there, that is why is a 16-bit address stored in memory in the reverse order? The lower order byte first, followed by the higher order byte, like you have used already in your, I think, practical class. That is, if it is written as STA 9000, so 9000 will be processed first, 90 will be processed last. Why? Because this has to do with the design of the 8085 microprocessor. And here the instruction decoder or the associated microprogram is designed to recognize the second byte as the lower order byte in a 3-byte instruction. Okay, so that is the uh, reason of having this.